Hey, what's going on, guys? Let's see how to prove this proposition. Here this proposition says for all a belongs to a real number, if for all x belongs to a real number, ax is less than or equal to x, then a is equal to 1. So whenever we have if then statement, we have to take the one that's after then. That's our claim. This is our claim, and this is the one we have to prove. In order to prove this claim, we have to use this one and prove this one. Okay, first of all, we let a belongs to a real number, and also we have to assume for all x belongs to real number, ax is less than or equal to x. We are just using the first statement, and we know that 1 is belongs to real number. If 1 is belongs to real number, it means we know that a is belongs to real number, so instead of a we plug 1 right here. Okay, for all x belongs to a real number, instead of, actually we have to plug it for this x, because we want to prove a is equal to 1, so we want to plug it for x. So this is going to be a times 1 is less than or equal to 1. So from this one we get a is less than or equal to 1, and also we know that negative 1 also belongs to real number. If negative 1 belongs to real number, it means a times negative 1 also less than or equal to negative 1 by this statement. Now here we have a times negative 1. Negative a is less than negative 1. It means if we change the sign, it's going to turn around. A is greater than or equal to 1. Okay, so here we have a is less than or equal to 1, a is greater than or equal to 1. It means it cannot be greater or less than, it should be equal. So from this one we know that a is equal to 1, so we prove this one, and that's how we prove whenever we have this kind of situation. I hope this helps. Thanks for watching, and if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.